Hello students. In our DME class, we were discussing the design of flange coupling, and yesterday we have discussed this question. We have covered this question. First of all, we have designed the hub after calculating the diameter of the shaft. Then we have designed for the key, and then we have designed for the flange. These three things we have covered yesterday, but today we will cover the design for bolts. So first of all, let's see the diagram. This small d1, suppose it is the diameter of the bolt, and this diameter of the bolt you have to find. So let for diameter of the shaft is 35. So for 35 diameter of the shaft, the number of bolts you will select is 3. The pitch circle diameter of the bolt, that is d1, d1 is equal to 3d. This is pitch circle dia, and this is 3d. So after getting the pitch circle dia, the bolts are subjected to shear stress due to torque transmitted. We know that maximum torque transmitted, that is torque, we have calculated 215 into 10 raised to power 3 is equal to area into stress, that is pi by 4 into d1 square, area of the bolt, into stress, that is shear stress in the bolt. N is number of bolts, and this is force, and multiplied with radius, that is d1 by 2 is the becomes the torque. So put the values of shear stress, that is 40, number of bolts, that is 3, d1, that is 3d 105 divided by 2. So from here we will calculate the diameter of the bolts, that is d1, and d1 will be 43.43 and d1 will be 6.6 mm, and assuming coarse thread, the nearest standard size of the bolt is m8. So m8 is your final answer of the diameter of the bolt. Other proportion of the flange, like outer diameter of the flange d2 can be taken as 4d, and 4 into 35, that is 140 mm. So thickness for protective circumferential flange. Now TP is equal to 0.25 into d. This is the case when you have a protective type flange coupling, but if you have unprotected type flange coupling, this step will be skipped. So for protective type flange coupling, thickness of the protective flange is 0.25 into d. Put the values of d and you will get 8.75. So this completes your first question. Next question is design and draw a protective type cast iron flange coupling for a steel shaft transmitting 15 kilowatt at 200 rpm and having an allowable shear stress of 40 megapascal. So this is the given data. First of all, power is 15 kilowatt, 15 into 10 raised to power 3 in watt, and RPM is 200. And shear stress for the shaft is 40. Working stress in the bolts should not exceed 30 megapascal. So shear stress in the bolt is 30 megapascal. After that, assume that same material is used for shaft and key, and that the crushing stress is twice the value of shear stress. This line indicates that you will use square key. The maximum torque is 25% greater than the torque. So 25% greater will be your maximum torque. The shear stress for the cast iron is 14 megapascal. So tau c, that is cast iron, which is hub and flange. The cast iron shear stress is 14 megapascal. So first of all, you have to repeat all the steps you have done yesterday. Find the torque from power and RPM. You will get the torque as 716 Newton meter and convert it into Newton mm. Find maximum torque by multiplying 1.25, because your maximum torque is 25% greater than mean torque. So you will get your maximum torque as 895 into 10 raised to power 3. So after calculating maximum torque, equate it with pi by 16 tau d cube and put the value of shear stress, and you will get the diameter of the shaft d, that is 50 mm. After getting the diameter of the shaft, you have to calculate the diameter of the hub, that is d capital D, which is 2d, and just find diameter of the hub 100 mm and length of the hub will be 1.5d, and you will calculate it as 75 mm. Let us now check the induced shear stress for hub material, which is cast iron. So now you have to check the design for hub. How will you calculate? Assume the hub as a hollow shaft and put the value of torque into pi by 16 tau d4 minus d4 by d. In this formula, put the value of the diameters and calculate shear stress. This shear stress is 4.8, which is less than 14, the given value of a cast iron shear stress. Therefore, design of hub is safe. After that, you will design the key. Again, repeat the same steps. The shear stress is half of the crushing stress, or we can say crushing stress is twice the shear stress. Therefore, we will use a scale key. From table, we can see that for 50 diameter of the shaft, you will use a key whose width is 16 or you can directly calculate by dividing 50 by 4. You will calculate the width of the key. Equate the width and thickness because we will use a scale key. So the length of the key will be equal to the length of the hub, that is 75. Now we have to check the design for key. How will you check the design? We apply the formula for torque key under shear. Torque is 895 into 10 raised to power 3 L into W tau into D by 2. Put the values of length, width and diameter. You will get the value of the shear stress for the key and the answer is 29.8. And the crushing stress for the key. Apply the formula for torque and for key under crushing. Torque is equal to length into T by 2 sigma Ck into D by 2. Put the value of the length, thickness and diameter and you will get the crushing stress for the key, which is 59.6. Since induced shear and crushing stresses in the key are less than the permissible values, therefore design for key is safe. Again, you have to design the flange. First of all, you have to find the thickness of the flange and the thickness of the flange is 0.5 d. So find the value of thickness of flange and check the design for flange. That is torque is equal to pi d square upon 2 tau c into tf. Put the values of diameter and thickness of the flange and find the value of the shear stress for cast iron, which is 2.5 and it is less than the given value 14. Therefore design of flange is safe. In the last step, you will find the diameter of the bolt that is designed for the bolt. First of all, assume D1 as the diameter of the bolt and the diameter of the shaft is 50. So for 50 shaft, the number of bolts will be 4 and pitch circle diameter will be 3D, that is 150. The bolts are subjected to shear stress due to torque transmitted. We know that maximum torque transmitted is torque is force into radius and force is area into stress. So area is pi by 4 d1 square into tau into n will be number of bolts and d1 by 2 will be radius. Put the values of diameter, torque, number of bolts and pitch circle dia and you will get the value of shear stress for the bolt. And shear stress for the bolt is given to you and it is 30. So put the values and you will get the diameter of the bolt as 11.25 or we can say M12 will be your diameter of the bolt. And the lastly you will calculate outer dimensions, outer diameter of the flange. D2 is equal to 4D. Put the value of the D, that is 200 and thickness of the protective circumferential flange 0.25D. Put the value of the D and you will get 12.5 as the thickness of protective circumferential flange. So both the numericals are similar. In any question of the flange coupling, the steps will be same. You just have to remember the proportions and how to check the design and some formulas. And hope you guys understand. In the next videos, we will discuss the design of flexible coupling. Thank you.